Welcome back. This is Ms. Warnow. We're going to continue talking about measurements. Scientific measurements are limited by the degree of exactness or precision that the measuring instrument gives us. So we talked about already, if we were going to use this tool here to make the measurement of this paper clip, we can look at the increments on the ruler, and you can see it's in increments of a tenth, so we'll read this as 2.1, 1, 2, 3, and it looks like it's just a little bit kind of in between that 3/10 and 4/10 mark. So I'll put a 5 here, and we would record that as 2.35. We're estimating one digit beyond what's marked on the ruler. We call this term is significant figures. Certain instruments can give us more significant figures than others. So if we saw a measurement of 35 grams and a measurement of 35.532, this measurement shows more precision. It has more decimal places, and like measurements that can give us the most precision. So which measuring apparatus would you use to deliver 9.7 milliliters of water as accurately as possible? Right? And so we have here a graduated cylinder. We have another graduated cylinder that goes up in increments of 10. This one goes up in increments of 1. We have a beaker and another beaker here. So we'll use the 10 milliliter graduated cylinder, which would be accurate to 2 significant digits because each one of these is the 1, and so you'd measure out to the 10th spot. The number of significant figures in a measurement is important because when we use measured numbers in a calculation, we have to round our answers to reflect the precision of the original measurement. And this way, people who are looking at the measurement can tell what kind of tool was used. The least precise measurement, meaning the one with the fewest significant figures, will limit the precision of the final answer. So first what we have to do is be able to look at a number and tell how many significant digits does that particular number have. So here are the rules for counting significant figures. I'm going to explain each one of these. You're not going to necessarily be asked to write these rules, but you do have to be able to use them. So the first rule here says any number that isn't a 0 is always significant. So any digit between 1 and 9 is always significant. So if we look at this 6.15, we have 3 significant digits, 1, 2, 3. We look at this number and we count those up, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this one's pretty easy. It's when we get into zeros that kind of can get a little confusing. So make sure you're paying special attention to these. So zeros that are between two non-zero numbers are always significant. So in this case, these zeros here are significant. So this has 1, 2, 3, 4, 5, because these zeros are between the 1 and the 2. Leading zeros are not significant figures. They only act as placeholders. So if you have a decimal in the problem and you look and you have these leading zeros, we do not count them because they're merely holding a place value there. And so this one has 3, 1, 2, 3. This one, leading zeros, doesn't count. We only have the 1 sig fig. Zeros, pull this up a little bit. Zeros that come at the end of a number are only significant if the number contains a decimal point. So these zeros come at the end here, and you don't see a decimal, so those do not count. They're also placeholders, so this one has 2 significant digits. This one has a decimal, so we do need to count these. So this has 1, 2, 3, 4, 5, 6. This one here has a decimal, so we need to count these. That would be 3. This one has no decimal, merely placeholding, so there's only 1 significant figure. And then for values written in scientific notation, all digits in the coefficient are significant. So this is scientific notation here, so all 3 of those are significant, and all 2 of those would be significant. Okay, so let's work a few practices with this. So how many significant figures are in each one of these? So this one has 1, 2, 3. This one has those zeros, but do you see a decimal? No, so these zeros do not count, and you only have 3 significant digits. This one has 4. This one has a 0, but it's a leading 0, so it doesn't count. 3. This one has zeros, but they are leading zeros, so this only has 3. This one has zeros, but they are leading zeros, so we don't need to worry about those. This one's scientific notation, so all of the coefficient counts. Scientific notation, so all of those count. And this one has zeros. We don't see a decimal, so those trailing zeros do not count, so there's only 1. Now we do have a decimal, so these do count. It's 4. So for the zeros, a good thing to do would be to look to see whether there is a decimal. Okay. So pay attention to the decimals with the zeros. Some numbers have an infinite number of significant figures, so we won't necessarily put all the zeros that go with them. So an exact number, a counting number, in the example here, you count the number of eggs left in the carton to be 8. We don't have to write 8.000000000, etc. We can just say it's 8. It has an infinite number of significant figures there. Okay. Numbers that arise from definitions are also exact. So when we say 1 meter equals 100 centimeters, that's exact. We don't have to write 1.00000, etc. out to 100.0000. We say those are exact. They have an infinite number as well. When we are doing math with significant digits, we have special rules that go with adding and subtraction as well as multiplication and division. So when you're adding or subtracting, you're going to round the answer so that it has the same number of decimal places as a measurement with the least number of places past the decimal. This would be the least precise measurement. If a measurement does not have a decimal place, use the measurement with the least number of place values. Example, you have 7 centimeters plus 445.9 centimeters plus 84.22 centimeters plus 78.990 centimeters. So when we line these up and we add these all together, you get 616.11 in the calculator. But since this is addition, we have to look at the places to the right of the decimal. This has 1, this one has 1, this one has 2, and this one has 3. So we're going to go with the least. So our answer should only have 1 place past the decimal. So it should be 616.1. Looking at 58.55 millimeters minus 45 millimeters, we line these up. When we put this into the calculator, we get 13.5. But looking at, since this is subtraction, looking at the decimal places, this has 1 place to the right of the decimal, and this has 0 places to the right of the decimal. So your answer should have 0 places to the right of the decimal. So that should be 14 because this 3 is going to round to a 4. Now with multiplying and dividing, you round the answers so that it has the same number of total significant figures as the measurement with the least. So with adding and subtracting, you're looking at the number of places past the decimal. But with multiplying and dividing, you're looking at the whole number. So if we do 52.3 times 8.8, we first have to look at how many significant digits does 52.3 have. It has 3. 8.8 has 2. So we have to go with the least. And so our answer can only have 2 sig figs. So if you punch that into your calculator, you're going to get 460.24. But now that you know about significant digits, you have to take those into account. So we need 2 significant digits. So we start on the left, 1, 2. So then we look to the right of that last place and say, hey, is it going to say a 6 or will it round up to a 7? Since this number is a 0, we're going to leave it as a 6, so it's 460. Notice that I did not put that decimal there, because if you put a decimal there, now you have 3 sig figs, and we only needed 2. For number 2, 5 divided by, let me let me just point out that a centimeters times a centimeter is centimeters squared, just as x times x in math is x squared. So make sure you're paying attention to the math that's going on with your units as well. So if you did 5 divided by 2.2, this is division, so we need to look at the total number. 5 has 1 sig fig, 2.2 has 2, so we need to go with the least number. So when you put that into your calculator, you're going to get this number. And once again, now that you know about sig figs, you have to round that to the correct number of sig figs. So we need 1. So we come over here, we look at our 1 digit, look first to see whether or not it's going to round up or stay. And since the number to the right of it's a 2, we'll leave it, and it's 2 meters. Now, where did the meters come in? Meters squared divided by meters gives you meters. So please be aware and make sure that you're paying attention to your units. This concludes video 2. Make sure you've taken good notes. Come to class with any questions. You may want to rewatch those last few minutes again. Make sure you know the rules for adding and subtracting. And if you have any questions, please see us in class.